Welcome guys to my YouTube channel. In this video we are going to concentrate on electrical engineering. So if you may wish to do engineering, particularly electrical engineering, you may find this video to be helpful. So I'm going to introduce you guys to something which is commonly known as AC. So let's get started. In this video we are going to concentrate much on AC, but I'm going to start with DC. So I'm going to differentiate AC from DC. Okay, so DC is simply direct current. So this is simply direct current, of which current it flows current. So in this current is in one direction. So current will flow in one direction in here. Let's take for instance, this is current, limited current. This is current. Okay. So let's take for instance, this is my battery. I connect it to a resistance. Then my drawing agree. This is negative, this is positive terminal. So we are saying in here the current will move in this direction, which is convection current, which moves from positive to negative. So this is in DC. So we are saying in DC current flows in one direction. Okay. So graphically it looks like this. If I meant to graph it, it will look like this. Let's say for instance you may wish to graph voltage against time. So your graph will be like something like this, which is constant. So you're having constant voltage. It can be voltage or current. It will be constant voltage. Okay. So this is all about DC. So let's also talk a little bit about AC. So AC, we are saying this is alternating current. So this simply means alternating current. This is current. Okay. So in here you find it's a kind of an electric. Let's say we write it an electric. Okay, current which devices. Okay, so this is the basic definition of this one. We are saying it's an electric current which devices. So we can say in contrast to DC. And we mentioned earlier, we said DC, the current just moves from into one direction, move in one direction. So this is also important. So in contrast to DC, which move in one direction. Okay. So this is a sample. For instance, we are saying we're having this. I connect this to, let's say, a resistance. In here, the current will move in this way, will also move in this direction. So this is my current, this is my current. So you have seen that the current is moving in this direction, the other one is also opposing. So this is what we mean when we say current reverses. So that's what we mean when we say current reverses itself. So graphically, this is sinusoidal function which looks like this. So this is time. This is voltage. Okay, so if you plot it, it looks like this. So I'm going to take a little bit of my time to explain about this graph. Okay, so in AC, the other thing we have to understand again, it oscillates 60 hertz per minute. So 60 hertz per minute. So it's in 60 hertz per minute. Okay, so that's implied that your frequency is equals to 60 hertz, which is your frequency in this graph. Okay. So from there, let's also take a close look at these graphs. And I introduce you guys to something which we normally use to calculate alternating current, which is moving in a circuit. So I'm going to redraw this graph and try to put a red bit stuff. Okay, so this is my graph of AC. This is time. This is voltage, which I'll just say this is voltage maximum. Okay, so this point here is a maximum voltage. So all this is simply a peak value. Even this one is same. Here is also a peak. So down here I will have my negative voltage. This. So this is how it looks like. So we are saying Vmax. In other way, we are saying Vmax is simply equal to peak, of which this is also equal to Imax, which is current, because you discover that these two, which is current and voltage, they are in phase. Let me just use this term, they are in phase. So this is in phase. This is important. They are in phase. Why are we saying that? So we are saying V is equal to IR, isn't it? V is equal to I. So we increase voltage, we also increase current. We reduce current, we also reduce in phase. So the formula we use to calculate either voltage or current is this. Alternating, we're saying this function of t, which is a function of t, which is voltage, is equals to V max sine omega t, like this. So this is the formula we'll be using throughout our calculations for voltage. When, let's say we want to calculate I. So we know from this one, we know for sure to say we have something which will look like this. Okay, if I have just made I the subject of formula, so I'm having something here. This implies that the general formula for I max to be like this. So I max, or I function of time, it will be like this. So where is V? I'm going to replace this thing which is here. So I'm going to say V max over R multiplied by sine omega t, like this. So this is what it means. So this is important. Just a recap, we said AC is alternating current which reverses itself. So we said if this is the function graph of AC, we are saying this is the maximum current, this is a minimum, which is a negative current or voltage. We can use whichever here. So this is what we mean when we say AC. So Just a quick example on how to calculate AC. Okay, this is the example here. I'm having one of the example. So the question goes like this. Suppose the standard line voltage is 120 in a typical household. What is the peak voltage? Okay, so we know that peak voltage is same as Vmax, just same as peak. So we are saying these, they are just one and the same thing. Now I'm going to introduce you guys to this formula, of which in the next video I'm going to explain how this formula came about. Okay, this is Vmax. Okay, we are saying Vmax is equals to Pk. Okay, so we are saying Vrms is equals to Vmax over root of 2. So I'm going to explain a lot about this formula when we come in the next video. Okay. So in this question we have been given Vrms. So from our data we know that Vrms is equals to 120. Then what don't you have? You don't have Vmax, of which Vmax is simply equals peak value. Okay, so we are saying if I can make Vmax, which I can even write it like this, so don't get confused. I'm just writing it like this. This is the same as Vmax, which is equals